Right, so yeah, I will ask you to finish that exercise if you haven't done for homework. We're going to move to shift. Okay? So I've drawn again, and this needs to be in your mind. These sine and cosine graphs are like the father and the mother. That there has to be the father and mother graphs. They have to be always etched in your brain. That's always your starting point. And now let's have a look at color. Y equals sine theta plus 1. Or maybe I'll write it. I don't want to do it exactly. Yeah, they did it the same, so I'll do it the same. Plus 1. Yes, Leo.
The whole thing will be up on
Exactly. Okay, this is what we call a vertical shift. Vertical shift. Okay? Shift, you understand what I'm saying. Vertical, exactly, it's upward. In this case, it's up. It could be down. We'll see one down in a second. So, how do I know that? Because again, you've got to look, okay, when sine theta, when sine 0 is 0, if I'm adding 1, this point is going to move now to 1. Okay? This point, sine 90 was 1, so that's going to move up to 2. Okay, so we're going to put a 2 there. The 180, sine 180, which was 0, is going to move to 1. The minus 1, sine 270 was minus 1, that was going to move to 0. The 360, which was 0, is going to move on to 1. And I'm going to stop here. That graph carries on, but we're not interested in the rest, okay? And then I'm trying to draw a nice round graph. Okay, and it can carry on as well. I'm not going to worry about that. And as Leo said, this whole thing basically gets shifted up. So now I just did it point by point, and I suggest you do the same. But later on, maybe next year, you'll be able to draw it straight away. You know that by plus 1, everything moves up 1. Pretty easy, yeah? Question, I'll just pause. Okay. Right, so before we combine everything like Luana suggested, let's just work on what happens if we have, let's say, y equal sine theta minus half. It's going to go down by how much? About half. It's easy, isn't it? So I'm going to do it really quick. So the 0 is going to go down to minus 0.5. The 1 will go to 0.5. Okay? The 0 will go to negative 1 to 0.5. Am I doing it right? Yes? The minus 1 will go down to
negative 1,5.
negative 1,5. Okay. And the 0 is going to go to
0.5.
minus 0.5. And we draw that. And voila. And it carries on. Okay. So it's shifted down by half. Okay. Let me ask you a couple of questions to see what changed. Did the range change? Range is the angles that we're working with. No, it's still from 0 to 360. It carries on, but we stop at 360. Did the period change?
No.
It still started repeating itself at 360. You're right. It didn't change. Did the amplitude change?
Yes.
The answer is no. Okay?
What?
Oh, okay, I see why.
How do you
because
get amplitude?
Okay.
everything
How do
moves.
we get the amplitude? I'll just demonstrate that to you. Let's see here. Now, you might say, hang on, sir, this is 0.5. The distance from 0.5 to the 0 is just 0.5. Isn't the amplitude 0.5 and not 1? It was 1 before.
The line
So
also moves.
The line, the equilibrium moved as well. The equilibrium now, it's not a 0. Where is the equilibrium?
0.5.
Minus 0.5. Everything shifted down. So maybe the definition from the textbook is the easiest way to calculate the amplitude. And I'll show you why. So the amplitude in this case will be half times the maximum. I'm looking at the green graph. What's the maximum?
0.5.
0.5. And the minimum? Minus what? Minus 1.5. Okay, because this is below, this is minus 1, this is minus 1.5. So how much is that? It's half. What is 0.5 minus 2? Is 2. And the amplitude is still 1. So shifting doesn't change the amplitude. What changes the amplitude? We already looked at what changes the amplitude. Stretching. Stretching did change the amplitude, okay? All right, I'll pause for questions. So, just as Luana asked me before, what happens when I have a combination of a stretch and a shift. So in this case, right, we've got a stretch because we time the cosine by a number. That we know that's a stretch, okay? And then we have a shift. Now I'm going to give you a very, very important principle, okay? Okay? First, stretch. Then, shift. Very, very important. Start by stretching your graph and flipping. When I say stretch, you might have to flip. In this case, we have to flip. And only then do that shift. So, in my mind, again, I told that to Lorna, you need to be able, before you start, you're looking, all right, do I have a sine or cosine? I've got a cosine. Is this recording? Yeah. So I've got a cosine. So in my mind, I just think about the shape of the cosine. For you guys, draw the shape of the cosine. Actually draw it. Okay? Now, what is minus 2? What, can you tell me in words? What am I actually doing to this graph? Am I stretching or compressing?
Compressing.
Okay, I'm making it small.
Negative
Negative number.
Okay, but is the amplitude going to grow or is it going to get smaller? I'm stretching it, guys. I'm stretching it. Okay, if this, okay, I know it's less than 1. I know what you mean, but you forget about the minus for a second. Okay, is the amplitude, because now I've got 2, it's going to get stretched because I'm timing it by 2. What does the minus do? Flips it. So I'm stretching it and flipping it. Okay? If that's not still clear, don't worry about it. Just ask yourself, right, what happens to this graph in 0, 90, 180, 273, 360? When theta is 0, the 1, what does the 1 become?
Minus 2.
Minus 2. So I'm going to draw a point minus 2. I'm not going to bother with 45, even if it's drawn on your graph. It's too much time. When it's 0, what will happen to it? And by the way, I haven't looked at the minus 1 yet, yeah? Maybe I'll use another color. I'll use another color. So that's going to be 0. When this is minus 1, what will happen to here?
Plus 2.
It will be plus 2. Can you see how it's stretched? Okay? When it's 0, it stays 0, right? That's easy. And then what else?
Minus 2.
And when it's 1, what would it be?
Minus 2.
Minus 2. So if I didn't have this graph, if I didn't have that minus 1, I'm going to be drawing, I'm going to do it like a little dotted line so you'll see what it is. You don't need to draw it, but just to see it, okay? So that is the graph minus 2 cosine theta. It's a stretch and a flip, okay? But that's not what they're asking. What they're asking is minus 1. So what do I have to do to this dotted line?
You bring it down.
Bring it down. How much? By 1. So minus 2 will become minus 3. The 0 will become
Minus 1.
minus 1. The 2 become
1.
the 0 become
Minus 1.
and the minus 2, it doesn't look like minus 2. The minus 2 will become
Minus 3.
minus 3. And that's the graph I'm interested in. Okay? So I'm going to try and connect it nicely, making it nice and round, right, Luano? You know, like what? Okay? And like this. Okay? Alright? So we've got a stretch and a downward shift. And actually a flip as well. Alright? First stretch, then shift. Okay, I'll just pause here for a second. Okay? Okay, so now when we learned, okay, the combination of stretch and shift, we can see the general, what does the general sine cosine graph look like? So we're going to look at 2 kind of graph. Y equal, I want to just draw it, write it down just as they do it. So they write down the A first or after. Sorry guys. Here we go. Okay. So A sine theta plus Q and Y equal A cosine theta plus Q. That's what all the graphs that we're going to be working on this year. We're going to add to this repertoire next year. Okay? Now, we need to figure out what are these A and Q. And I think you can tell me, Leo, what is the A?
Good.
A is your stretch. Okay? Right? A is the number in front of sine. It's the stretch. Okay? That is going to be your stretch. And what is the Q?
Shift.
Shift. and I'll be more accurate, it's the vertical shift. Okay? Let's try a bunch of stuff. If A, I'm not going to write, so let's say A is between 0 and 1. Is it going to be stretched really or compressed? Like A is a half. What will it be? Compressed. If A is larger than 1, what would you say it is? Stretch. If A is smaller than 0, what would we call it?
Stretch.
It's a flip. It could be a stretch and a flip, or it could be a compress and a flip. But if we have a negative A, like we had here, we are flipping it. I can say, right, between 0 and -1 is going to be a flip and a compression. But smaller than -1, it will be a stretch and a flip. But never mind that. Let's look at Q. When Q is larger than 0, okay, it's a shift. But shift in which direction? Yeah? Shift up. If A, no, we're looking at Q now. If Q is smaller than 0, it's shift down. Okay? So this is all the equation we're going to work on. I'm going to remind you that next lesson, and we're going to practice it a little bit more. Okay? For homework, guys, please finish these two exercises. Okay?
So you want us to do C?